Now we start critical velocity from gravitation. So we already used the term critical velocity in procedure to launch a satellite. Now what is critical velocity first? Question may be asked, what is critical velocity? Obtain its expression. Derive its expression. Now critical velocity means it's a horizontal velocity due to which satellite revolve in a circular orbit. The horizontal velocity given to the satellite due to which it revolve in a circular orbit is called as critical velocity. Now let me start the expression for critical velocity. Expression for critical velocity. Now pay attention here. So we have to consider a satellite whose mass is m, small m. Consider a satellite of mass m revolving in a circular orbit. If it is revolving in a circular orbit, then only velocity is the critical velocity. Consider a satellite of mass m revolving in a circular orbit at height h with velocity vc. We consider these three terms. Satellite of mass m, height of the satellite, and critical velocity means velocity of the satellite. Now let I consider capital M, mass of earth, capital R, radius of earth. I consider small r also. What is small r? Small r is radius of orbit, or I can write r plus h, or radius of orbit. Let I show the radius of orbit in a diagram. If I consider, so I think this is visible portion. So this is earth, or I will show it here. Okay. Okay, this is portion is visible. Okay, this is earth. I am showing a little smaller diagram. This is radius and the satellite is at height h. So this is height h. Satellite is revolving in a circular orbit. Let I show the circular orbit here. This is a horizontal velocity. Now this r plus h is the radius of orbit. Now we already learned in the circular motion article, for circular motion of the satellite, centripetal force is required, or you note these things. So this centripetal force you have to learn in the 12th standard also. But here you remember, for any circular motion, centripetal force is required. And in this case, why the satellite is revolving? Because of the gravitational field. You know that why moon revolving around the earth? Because of gravitational field, because of gravitational force. Here also, the centripetal force means which force responsible for the circular motion is the centripetal force. It means that here in this case, centripetal force is a gravitational force. For circular motion of satellite, centripetal force provided by gravitation. Hence, I can write it here. Centripetal force. Centripetal force is equal to gravitational force. Gravitational force. Now centripetal force formula is mv square by r. mv square by r. Now mass of the satellite is m, velocity is vc. So instead of v I write here mvc square by r. Okay, this is centripetal force formula that you have to remember. Gravitational force, by Newton's formula we know that F is equal to g m1 m2 divided by r square. This is the gravitational force. Now here g, I write g. Mass of first object, m1 means mass of first object, it is earth, capital M. Mass of second object means satellite, small m, divided by r square. R means distance between these two. You can see satellite is here and earth is here. We have to measure distance from the center, so smaller. Now I can cancel the common term, this r and one r from r square, m, one m get cancelled. So we get formula for vc square. So gm divided by small r. Or I can write formula of vc. So under root gm divided by r. And this is expression for critical velocity. Or the same formula I can write under root gm divided by r plus h also. Because this small r stand for r plus h radius of the orbit. So we can write the formula like this way also. This is expression for critical velocity. This is expression for critical velocity. Okay. Now if in examination question is asked, what is critical velocity? You have to write definition. The horizontal velocity due to a satellite revolve in a circular orbit is the critical velocity, or is called as critical velocity. Then this expression, consider satellite of mass m revolving in a circular orbit at height h from surface of earth with velocity vc. And then as it is up to, you have to write up to this. Now let me modify this equation, but we know that g at height h is equal to gm divided by r plus h. So this formula we already learned. By using that we can write, hence gm is equal to gh into this r plus h. So we get this formula, gm divided by r plus h, sorry, r plus h square. So r plus h square here. Now let us substitute this gm here. Hence critical velocity is equal to under root, instead of this gm I write this gh into r plus h bracket square divided by below r plus h. This one r plus h and one r plus h from the square get cancelled. So we get critical velocity is equal to gh into this r plus h. So this is also expression for critical velocity in term of acceleration due to gravity at that height. Now after that, if satellite is close to surface of earth, if satellite is close to surface, that is h is very less as compared to r. If satellite is close, this height is very small as compared to the radius of earth. You know that radius of earth is 6400 km. And if satellite is at 100 km from the surface of earth, then this distance is very less as compared to 6400. Then we can neglect height. Hence, neglecting h, we get. Now what we get? We get critical velocity is equal to, by this we can write gm divided by r plus, r. Now h we are not taking. And if I use this formula, then we can write critical velocity is equal to under root g into r. Under root g into r. Now here, the value of capital G is fixed, capital M is fixed, capital R is fixed. If I substitute all the values, then we get critical velocity is approximately 7.92 km per second. So this is the value of critical velocity. Now if someone asks you question in MCQ, how much is the critical velocity of satellite revolving at height 100 km from the surface of earth? 100 km means it is very close. So the speed, critical speed or critical velocity is 7.92 km per second, that you remember. So I hope everyone understood this critical velocity article, very important. You have to prepare it very well. Now after that critical velocity, we have to learn the next article, and it is binding energy of revolving satellite. Binding energy of revolving satellite. Binding energy. Now listen here. First thing, what is binding energy? Binding energy means the energy with which satellite is binded to the earth is the binding energy by the word. Now if you want to free the binded satellite, then how much energy we have to provide? We have to provide the same amount of energy with it is binded to the earth, and then only it is free from the gravitational field. So in another word, we can define the binding energy, the energy, the minimum energy, the maximum if you provide then it will free, but the minimum energy required to free a satellite or object, not only the satellite, object from Earth's gravitational field is called as binding energy. If this is a pen, if you want to free it from gravitational field, now here if I release the pen, it fall down because of the Earth's gravity. So if you want to free the pen from Earth's gravitational field, then how much energy, minimum energy you have to provide to it is the binding energy for this object. But here we are binding energy of revolving satellite we have to discuss here. Now here binding energy. I hope everyone understood binding energy. If someone asks define binding energy, then minimum energy required to free a satellite from Earth's gravitational field is called as binding energy. Then expression for binding energy. Again same thing. Consider a satellite of mass m revolving at height h in a circular orbit with velocity vc. Let capital M mass of Earth, capital R radius of Earth, small r is the radius of orbit and it is equal to r plus h. Same diagram. Then we have to find out binding energy. Means first we find out the energy with which it is total energy with which it is binded to the Earth. With what energy the satellite is binded to Earth, that we find out, and then same energy we have to provide to free it from the Earth's gravitational field. Now it means that we have to find out total energy. So first we find out kinetic energy. So we find out kinetic energy. So kinetic energy, you know that half mv square, but velocity is vc. Then 1 by 2 m as it is. Critical velocity, you know that under root g m divided by r plus h, or small r also you can use, square. So after solving this we get g m divided by this 2 and this r plus h. Equation number 1, we get kinetic energy. So we have to find a total energy. Then total energy means we have to find out kinetic energy, we have to find out potential energy, then we have to add both the energies, then we get total energy. Okay, now potential energy. Potential energy of the satellite. Potential energy, we learn one formula of gravitational potential or electric potential you learn. So work done to bring a charge from infinity to point in electric field is the electric potential. Similar manner, gravitational potential is work done to bring a unit mass. So this work done is the potential energy. Work done is the potential energy, then this gravitational potential into the mass. So I can write here, potential energy is gravitational potential. Gravitational potential into mass of satellite. Now here gravitational potential is minus gm by small r or r plus h I can write, and mass of satellite is small m. So we get potential energy minus gm divided by r plus h, equation number 2. So this is potential energy. So we get kinetic energy, we get potential energy. Now we can find out total energy. So I can put the heading here, total energy. So total energy is equal to kinetic energy plus potential energy. So total energy I can write TE. Kinetic energy is this, Gmm divided by 2 R plus H plus potential energy. Potential energy is negative, so minus this, Gmm divided by R plus H. So this is total energy. Now we can add these two. We can take this Gmm divided by 2R plus H common. Then in a bracket we get 1 by 2 minus 1. 1 by 2 minus 1 is minus 1 by 2. So here this addition is coming minus 1 by 2 into this common factor Gmm divided by R plus H. So I can write this in a different way, Gmm divided by 2 R plus H. So this is the total energy, equation number 3. So we get total energy with which satellite is binded to Earth. And if you want to make it free from that point, we have to provide a same amount of energy, but in opposite direction you can say. Hence, binding energy is equal to, I can write binding energy is equal to minus of the total energy. So this minus and the total energy is already minus. So this minus is plus. So plus GMM divided by 2R plus H, and this is expression for total energy. Sorry, binding energy. Yeah? So this is expression for binding energy. This is binding energy of revolving satellite. I hope everyone understood what is binding energy. Now here you can see this is a kinetic energy. This is a binding energy. So here binding energy is equal to kinetic energy. Both the formulas are same. Now you can see here total energy. Binding energy is equal to minus of total energy. So minus of total energy. Now you can see potential energy. So potential energy and binding energy, only here 1 by 2 is not there and minus sign is there. So I can write minus 1 by 2 of potential energy. So this is a relation between all these energies. I hope everyone understood this article, binding energy of revolving satellite. I think here we can find out binding energy of object on surface of earth also. Only the thing, if the object is placed on surface of earth, then same way kinetic energy is 0. Because if it is placed on surface of earth, binding energy of this pen you have to find out. Then pen is at rest, so kinetic energy 0. Potential energy same. Then R plus H is not coming. It is on surface, it means that only R is, capital R is coming. So Gm divided by capital R into the mass of this pen. So you get potential energy and you add both the energies. Kinetic energy is 0. So 0 minus this Gm by R. So minus Gm by R is the total energy and Gm by R is the binding energy of this pen. So in that way also you can find out. So I will find out here the binding energy of the object at rest also. So binding energy of object. Binding energy of object at rest on surface of earth. Taken. Now consider object of mass m is placed on surface of earth. Then mass of earth capital M, radius of earth capital R. So this is not coming. Then kinetic energy. As the object is at rest, so kinetic energy is coming, or I can write half mv square. So v is 0. So it is coming 0, or we can write here 1 by 2 m0 square. So it is coming 0. Kinetic energy 0. Potential energy, gravitational potential into mass of object. Instead of satellite, I can use a mass of object. So here Gm by R is the gravitational potential energy, mass of object is this. So we get minus Gmm divided by R. So this is the potential energy. Total energy we can find out this. Kinetic energy is 0 and potential energy is minus Gmm by R. So this is the total energy. Now here we get the final formula. Minus Gmm divided by R, and this is the total energy. As we get total energy, binding energy is the minus of total energy. So we get this is the formula for binding energy of object at rest on surface of earth. You remember this one. So this is the binding energy of object at rest on surface of earth. I hope everyone understood how we get this binding energy.